suppose. There are questions? Yeah, which one do you have?
I just got curious. Here's the first question: how to calculate the rectangular?
Calculate the what?
Rectangular.
I'm not sure what word you're saying. Can you? No. It's okay. I'll figure it out. Can you spell it?
It's A-N-T-A.
A-N-T.
Wait, let me see.
And what word could this be? What does it mean?
It's
Well, anyways, it's in question 1, is it?
yeah.
Which lesson? Rectangular, okay. So, are we doing question 2 and 8, is it? Yeah? Yeah? Okay, 8 is, and 2 is what we're doing, yeah? Yeah? Is that what you need to see? Is it number 2?
Yeah, just know how to get the rectangular volume.
The volume. Yeah, fair enough. Okay. Is this one of these questions that they? What? Yeah. Okay, thank you. That would be easiest. Ah. Yeah.
So what I did first is to get the whole, and you get the volume of the box. Yeah. The triangle. Yeah. So
That's what I know. There's a formula, but that's what I would do too.
yeah, but
Let me draw it. Okay. So. Here, and then it goes up like this, and then it goes back off into the distance, obviously. And here, this is 2, and here this is 0.6, correct, yeah. And this distance here, the depth, is 3. What the heck is 8? Is this 8? Yeah. Yeah. Okay, so I'm going to split this here into 2 parts, like you said. And I'm going to get the area first, which will be 8 times 0.6, yes? Plus a half 8, which is 4, times 1.4. Right? Is that 0.58? Plus 5.6? Is that? I don't know. Help a teacher out here.
No, I was doing actually it's in minus, so get the whole box. So
Oh, I don't like that, but it works.
Yeah.
It works, but I don't like it. What's this here? Sorry, is it 6.18? Good. Now, to get the volume, all you do is you take this area and then multiply it by the 3. What's that? 18? There you go. That's the volume. Is it?
Yeah, no, mine says 21.2.
Yeah.
It's the 8. I don't think it's the. I think the 8 is that one.
No, the 8 is right.
No, well, no, I see what you're saying. Is the 8,
No.
yeah, is the 8 maybe this?
Ah, yeah.
Not this.
Yeah.
Is that it? No, if you look at the picture, it looks like what she's saying is right. It looks like the 8 is this distance.
No, it could be either way.
It could be either way.
So imagine the pool is flat there,
But
The deficit.
well, you know what? Look, what we'll do is we'll make the 8 and see what answer we get and see if it matches. Okay. So I need to recalculate. Okay, this is still 2, and this is still 0.6, and we think this is 8, and this part here is 1.4. So Pythagoras can give us the base then. What's square root of 64 minus 1.4 squared? 7.88.
7.88.
Oh, sure. That's only going to make this smaller if you replace that with 7.88. And you said the answer is like 31
31.
Yeah, 31.
for the volume.
Yeah.
What?
I actually did get that. So.
You got 31. Okay. Okay, I'm hungry. What have I done wrong?
Maybe some value there is.
Oh, yeah, here. 8 times 0.6 is not 0.58, Stephen. It's 5.8, isn't it?
No, 4.8.
It's 4.8, isn't it? 4.8 plus 5.6. That's better. What's that? 10.4? And then we have to multiply it by 3. Is what you got? And is that the answer in it? So, Regina, I feel like what you said is right. It looks like in the picture that this is the 8. Yeah? But the answer makes it so that this is the 8. Can you all look at the picture and tell me, what do you think? Do we think it looks more like this is the 8 or this distance is the 8?
I think the fact is this way. No, the top one.
I think it's also because if you read the question, it says the length is 8, which makes it this. What word would they have to use to make this be the 8?
Curve.
No, not this, yeah. Because curve is like this.
Slope.
Slope.
No, because you know slope in maths has a meaning of this.
The incline.
Go on.
Inclination. The incline plane.
Not inclination and not inclined plane. You're getting close though. If you want this to be the 8, you would describe that as the slant length. Slant length would be the describing that. Yeah? Okay? Yeah, so this was a bit messy, wasn't it? Yeah. But is it okay now? Yeah. Okay, and what did you say, Dorian? 8, was it?
Yes.
On the next lesson?
Yes.
Conservation momentum? What's so hard about this one?
It's not.
Ah, I like it. I like it. Oh, let's have a look at it. Okay, number 8 from the conservation momentum is you have a picture like this. I'll draw it. You have a mass here, M, and then you have a bigger mass down here, M, and this distance here is 30.0 centimeters. Oh, you know the masses. The big one is 100 grams, and the small one is 20 grams. And when they meet, they stick together, it says. Okay. First question. How fast is this going when it gets down to here? So what can we use to calculate this? Yeah, conservation of energy. So the energy here is mgh, and that will equal the energy here, which is a half m v squared. Because when it's here, it has potential only, and when it's here, it has kinetic only. Well, that's kind of nice. So that would be whatever the square root of 0.6 times 9.81 is. You have that calculated? What's that?
2.426
Meters per second. Then what happens is these two stick together and they move off together. And we want to know what is their speed. So what rule do we need now? The collision, conservation of momentums. So if it's going to the left, it's m1, u1 plus m2, v2, and then afterwards it's going to be 0.12 times x, we'll say, where x we think will be negative. Okay, so what do we get for x here?
I wrote 4.05 times 10 to the power negative 3.
No, that's no. No, it should be something like 4 or whatever.
Minus 4.0.
Minus 4.04 is what I would believe, yes. You must be typing in something off. Okay? Yeah?
The x is the velocity, right?
Yeah, well, yeah.
But the answer is
As well.
0.415 meters per second.
Oh, bad teacher. Bad teacher.
0.02, yeah.
Yeah, 0.02. 20 grams, not 200 grams. Bad teacher. No lunch for you today. Right. What's it now?
Minus 0.04.
Which is what Dorian said is the answer. Yeah? Okay, next. How much kinetic energy was lost? So, what was the kinetic energy at the beginning? But just before the collision. That's a half m v squared. And what's the kinetic energy after the collision? A half m v squared. And this number will be smaller. Okay? Does somebody can give me the two numbers here? So the KE went from blank to blank. These are the two values here. You have the numbers?
Yeah, it says 0.05.
2. Yes. Yeah, it's pretty small. And the first number was, it's a big difference. 0.5885. It's okay? Yeah, so, but they want the percentage, so we have to make it a percent. So, 0.05885, 0.05885 minus 0.00979 times 100. Yeah. Go. Got that? And lastly, what happened to most of this energy? What did it become? Yep. And heat. Here you go. Yeah. Thank you. Yeah. So what cut you out?
No, I wrote this, but I wrote something wrong.
Oh, okay.
Yeah.
Anything else we need to see? No? Yes? What do you think? Over on this side of the room? Anything we need to see? No? Regina? No? Okay, let's continue. So